we have learned that the trigonometric functions, they are applicable for right angle triangles, right?
Yeah.
Sometimes we have triangles that are not right angles. Not right angle triangles. Then how? So we need to have a way to deal with them. So let's do a bit more of understanding of what the trigo functions are actually like. Okay? We use this grid over here. This is your x and your y-axis. X-axis horizontal, y-axis vertical. Over here I drew a circle as well. Can you tell me what is the radius of this circle? 5 units, right? Because from the origin to this point, you have 5 units. Origin to the bottom, 5 units, 5 units, and 5 units.
Yeah.
Okay? Now, can you tell me what are the coordinates over here? What are the coordinates here? 0, 5 or 5, 0? 5, 0. Okay? 5, 0. What about the coordinates here? 0, 5. Okay, what about this one over here? Okay, negative 5 and 0. What about this one? Okay, 0, negative 5. So far okay, huh? So, where is the triangle? Now I am going to draw one straight line from the center to the circumference. What's a good point? This point looks good. Shall I join it here? Okay, can you tell me what is the length of this green line? What's the length?
1.
Why 1? Why 4? Wait. Listen to the question carefully. What is the length of the green line? 5 lah. You know why 5? Because the radius of the circle. Okay? The radius of this circle is a constant. So the length of the green line is 5. Okay. So if we were to use what we have learned previously for calculating a line, the length of a line segment, we will be able to do so as well. What are the coordinates here? 4, 3, right? So if I want to find the length of this line segment, I use my square root x2 minus x1 square plus y2 minus y1 square. There will be a length of line segment, and we will realize that it is equal to square root 3 square plus 4 square, which is 4 square plus 3 square, and we get 5. Okay, just a quick recap only. Okay, this is not the focus, but right now I am going to drop a perpendicular line down. Now you see a right angle triangle? Yes, the right angle triangle is over here. Okay? This is my right angle triangle. And I am going to call this angle over here theta. So far can follow? I have an angle theta between this green line and my x-axis. Okay, question. Now I ask you, if I ask you to find tangent theta, what is the answer? Do you know how to do it? Tangent theta, do you know how to do it? Say. Okay, wait. Sophia, what do you say? Shift? Shift tangent, no? Okay, Afiq, can you tell us why you say it is 3/4? Okay, Afik says that this vertical line over here has a height of 3 units. Hey, why do you say so? What is this called? The y coordinate. The y coordinate is 3, isn't it? So the height must be 3 lah. Oh, this 3 and this 3, they are the same. What about the x coordinate? 4. That is from the x coordinate. You see it? So this is equals to opposite, which is 3 over 4. Understand so far? Okay, so B. What about sine theta? What about sine theta? So sine, we have our opposite first, right? Opposite, which one is the opposite? 3 over 5. Hypotenuse, don't anyhow say, huh? Okay? Hoi, understand? And what do you think I'm going to ask next? Cosine. Cosine theta equals to 4 over 5 over hypotenuse, right? So far, can huh? Okay. This over here is the same as what is in your textbook, page 35. You see the circle there? The numbers 4, 5, theta, everything is the same. So now you understand what the diagram in your textbook means. Okay? But do all triangles have a hypotenuse of 5 units? So 5, huh? No, right? It could be anything. So this example over here cannot be used all the time unless we generalize it. What do I mean by that? Now, I am going to remove all of these. Okay? And I'm going to say that now I have one circle. Please ignore all these numbers. We don't want them anymore. Now, the radius of a circle, let's generalize it to be called, what do we usually call radius of a circle? What letter do we like to use? R. Okay? So that is in your diagram at the bottom. You have a circle with radius R. Okay, so again, I'm going to have one green line. Can you tell me what is the radius over here? R. Okay. That's what we call it lah. That's what we define it to be. Okay. Again, I'm going to choose one point over here. What do you think are the coordinates? Do we know the coordinates? Don't know, right? So what do we usually call something that we don't know? Yeah, X. Okay, so X and Y. What does this mean to us? This means that if I drop it down, what is this value over here? X. And what is this value here? Y. Okay, so far? And I'm going to call this angle theta. Oh, it's quite similar to earlier on, right? Just that now we do something a little bit more difficult. We don't use numbers anymore. We don't use our 3, 4, 5 because we are very comfortable with algebra. So now I have X, I have Y, I have R, I have theta. But don't worry, it's okay. It is just a representation of numbers only. That's all. Okay? Do you recall what we said was tangent theta? Do you remember what it was? What's tangent theta? Shamit, tangent, what is the ratio? What is the ratio for tangent? Sorry? What is O? Opposite over? Adjacent. Okay, so which one is opposite over here? Where is the opposite side? Ready? X is the opposite. Y is the opposite. This is, what is the height over here? This is Y, isn't it? This is X. So when I say tangent theta, I'm asking for opposite, which is Y over X. Okay? Next. Cosine. Just now I started with sine, right? Let's try sine. Sine theta this time. What is the ratio for sine, Darren? Okay, first you tell me opposite over hypotenuse. Okay, so opposite over hypotenuse, and he got y over r. Okay? And of course, the last one must be cosine. Will be your adjacent, which is x over the radius. Okay? So now I have described your theta with the three trigonometric functions in terms of x, y, and r. Can? By the way, just by the way only, this triangle over here, right? What is the relationship between x, y, and r? What do you think is the relationship between these three letters? Can we form an equation with them? Can we form an equation with x, y, and r? Sorry? Where got a square, where got b square? Yeah, okay, Afi got it correct. X square plus y square equals to r square. This is your Pythagoras, right? Okay, so that's just something extra only. You see that a lot of topics are related to each other. Okay, we can see different parts of different topics in another topic altogether, okay? So now, does anybody have any question about this general form? No? So, what kind of angle is this theta over here? Acute? Obtuse? Reflex? Acute. Acute because it is smaller than 90 degrees, right? And over here we have a right angle triangle. Okay, what happens if I have another angle? I draw another line over here. Let me draw it symmetrical. Symmetrical. Okay, my green line is symmetrical to the, my purple line is symmetrical to the green line. Okay, so please tell me what are the coordinates here? Still x? Negative x. Over here this is negative x. Because it is symmetrical, right? Over here, let's say x is equals to 4, then over here this must be negative 4. So over here I have negative x. What about the y coordinate? Is it also negative y? No, it is y. It is the same height. Okay, over here. Okay, so far? Okay, Okay, what about the length of this purple line? What about the length of the purple line? 5. Because the radius didn't change. So this is also 5. Huh? Oh, sorry. I mean it's R. Yeah, I confused this with my earlier example. Okay, so this is R. Okay, so far? Okay. Now, the angle in this topic, angles they are measured from this line. Okay? See the yellow color arrow? We measure angles from this line and we go anti-clockwise. What do I mean by that? So, your green angle over here, your theta, this angle theta is measured from your yellow line anti-clockwise until this line. So this is your angle theta. Okay? So nothing different from what we did earlier on. What about the angle for the purple line? No, it's still anti-clockwise. It is always anti-clockwise from this yellow arrow. Okay? So my purple angle, it looks like this. From here, yellow line, all the way to this side. This is my angle theta, purple color one. Okay? So different, but purple color. Okay? So far, is it too much to understand? Okay. If you don't want to call theta, never mind. Let's just call it, what's a good letter? A. Okay, let's call it A. This is angle A. That's it. Okay? So now I have a triangle. I have a green triangle, and I have this purple line with two different angles, with the same height, with the same base, but for the base, one of it is negative of the other. Okay, can you understand so far? Okay, so we are going to use these same things. This one does not change. Okay, we're going to use this to define angles, trigonometric functions of angles that are greater than 90 degrees. Okay? So let's pretend that, for example, earlier on, in our earlier example, we said that this was equals to, how much? 3 over 4, right? Just now we said it was 3 over 4, this one was 3 over 5, this one was 4 over 5. Okay? This was earlier on, the example. So now, if I consider this case, what can you tell me about this value, all these values now? Your x was 4, y is 3. Just now, 4 and 3. So what do you think are the values over here? Negative? Negative 4. Comma 3. Symmetrical, ma? The height, just now we said our example, the height was 3, right? And the base was 4. So this was 4, this was 3, this was negative 4. Okay? So this is what we have so far. I'm going to use purple. I'm going to consider tangent. What is this purple color angle called? What's the purple angle called? Is it also theta? No, right? We call it A. So tangent A equals to, now we don't have opposite, we don't have adjacent, all those kind of things already, because no more right angle triangle. But we are going to use what we have defined earlier on. We're going to use this to tell us what is the value of tangent A. Okay? So tangent A, just like tangent theta, is supposed to be y over x. So what is the value for y in this region? 3 over 4 or negative 4? Negative 4, because now my x value is negative 4. Okay, my y value is 3, x value is negative 4. You understand? Don't understand? Okay, rewind. Tangent A is also equals to y over x, okay? Because no change. Now you need to tell me what is the value of y. Over here, what's the value of y? 3. What is the value of x? Negative 4. See, negative 4 over here. Who does not understand this step? Raise your hand. This A over here refers to this angle, the purple color one. We are comparing the purple color angle with the green color angle. On top over here, we have tangent theta equals to y over x, right? We said that is confirmed correct. We said that sine theta is y over r. We said that cosine theta is x over r. These are confirmed correct. Now we are extending, all these are is only for acute angles. We are trying to extend this to angles that are greater than 90 degrees. So obtuse. We are extending this to obtuse angles in purple color. See, my angle A is more than 90 degrees, right? So we are extending to obtuse angle. So we use the same formula, tangent A, where A is greater than 90 degrees, it is equals to y over x, no change. But now, you need to think carefully, what is your value for y? It is, in this example, 3. So I get 3. And then x, think carefully, what is the value for x in this case? It is negative 4. So now I have negative 4 over here. Okay? Tangent A is now equals to 3 over negative 4, which is just negative 3 over 4 lah. Okay? So far okay? Now, next one, sine theta equals to, based on what we have said earlier on, y over r, right? What is the value for y? Mass. What's the value for y? 3. What is the value for r? 5. Yes, that's it. Okay, final one, cosine theta equals to x over r. What is the value for x? 4 over 5. Hey, really? 4. X equals to 4, meh? Negative 4. Okay? So, what have we learned from this diagram over here? Hey, why I write theta? This should be A. What have we learned over here? I am going to highlight it in green color. These are the important parts. Tangent theta is y over x. Tangent A is y over x. Sine theta is y over r. Sine A is also y over r. Cosine theta is x over r. Cosine A is x over r. You see that they're the same? It is constant. It didn't change. This is shown in your textbook, page 35. It is highlighted in a box. They have written down sine theta is y over r, cosine theta is x over r. Okay, you might want to add on. Tangent theta is y over x. In the box at the bottom. Okay? Alright, now I have a question. Let's observe this one. If the triangle, the angle is acute, when we take tangent of an acute angle, our answer, is it positive or negative? Is this positive or negative? When your angle is smaller than 90 degrees in this green triangle, I take tangent of this angle. Is my answer positive or negative? What do you see? 3 over 4, right? Is that positive or negative? It is positive. Think back. How did we get this 3? It came from the y-axis, this y-coordinate. And this region above the x-axis is a positive number, right? So you get positive 3. What about the x, the value 4? It is from the right-hand side of the y-axis. So you get a positive number again. So you get tangent of an angle which is smaller than 90 degrees. This is positive. Okay? What about sine? Sine, acute angle, is also positive. Because opposite, which is the height, is positive. And radius is also positive. Cosine. Cosine of an acute angle, we take adjacent. In this case, adjacent is also positive. The radius also positive. So all these are positive. You can try with your calculator. Sine, cosine, tangent, angle. Where the angle is smaller than 90 degrees, your answer will be positive. Okay? What happens if the angle is greater than 90 degrees but smaller than 180 degrees? In this case, the purple color case, where we have angle A. Let's look at the first one. Tangent A. Positive or negative? Is this a positive or negative number? It's negative, right? Why is it negative? Where did the negative sign come from? Is it from the y coordinate or the x coordinate? From the x coordinate. And why is that so? Because it lies on this side of the x-axis. These are all negative numbers. Because it is over here, because the x coordinate is over here, that is why your answer is negative. Okay? What about sine? Sine A. Sine A equals to opposite over your hypotenuse. The opposite is your y value, isn't it? Is this y value positive or negative? Positive. So that's why we have positive 3. Radius is 5. It is positive. So this answer over here is positive. And finally, we use the same logic for cosine. Cosine A is your adjacent over hypotenuse. Again, our adjacent is negative. So we get negative 4 divided by radius, which is 5. And we get negative 4 over 5. Okay, this is the relationship between theta, your tangent theta, tangent A, sine theta, sine A, cosine theta, and cosine A. Tangent theta y? The parts that are highlighted in green is common, whether it is acute, whether it is obtuse angle, also can use. Okay? It's just that when you press calculator, right, then sometimes your answer positive, sometimes negative. And this is the reason why. You go and try with your calculator. Sometimes positive, sometimes negative. This is the reason why. It depends on the size of your angle. Okay?